Look, memorizing physics facts without understanding how variables actually interact, that is exactly how students lose easy method marks and completely risk falling out of their target grade boundaries. I see it all the time. You memorize the equations, you learn the definitions, but the second an examiner throws a practical investigation at you, total freeze. Welcome to the ultimate variable pressure test. Today, we are stress testing your exam strategy until it becomes unbreakable. So, think about this. If you stretch a spring, which factor is independent and which one is dependent? This specific spring example exposes one of the most painful common learner mistakes in Cambridge Physics 0625. Students constantly mix up what they are actively changing versus what they're simply measuring. They write down their answers, kind of just assuming the examiner knows what they mean. But let me tell you, in the marking room, guessing the relationship between factors, that gets you absolutely 0 marks.
And honestly, this is exactly why ordinary revision fails. You can read the textbook 10 times over, but if you step into that exam hall without a rock-solid framework for identifying variables and structuring your data collection, your answers are just going to crumble under pressure. Missing units, vague explanations, totally wrong variables, these are not just minor typos, guys. They are the fatal flaws that examiners circle in red pen year after year. Rote learning just cannot save you when you're asked to design an experiment from scratch or evaluate a tricky data table.
Okay, let's get you your first quick win. We need to compare the flawed assumption of just guessing which factor affects the other against the top band method of knowing exactly which variable is driving your data. Knowing your variables is literally the only way to prove your scientific reasoning to an examiner. It basically screams, hey, I am completely in control of this investigation. So let's build that top band framework right now.
We'll start with the main driver of any experiment. The independent variable is the one that you, the experimenter, change. You are the one in the driver's seat here. You choose to change this factor first just to test its effects. So going back to our spring, the force or the load that you apply, that's your independent variable. You are the one deciding if you're adding 1 Newton, 2 newtons, or 10 newtons.
Which brings us right to the reaction. The dependent variable is simply what you measure or observe when that independent variable is changed. It's purely a reaction. You add the force, that's independent. The spring extends in response. That's dependent. It really is that simple. But identifying these two properly allows you to definitively prove which factor is affecting the other.
But to make your data actually mean something, you absolutely need this third piece. A control variable is any variable that is kept constant throughout your entire investigation. Think about it. If you're testing springs, you don't secretly swap out a stiff steel spring for a flimsy copper one halfway through the experiment, right? You keep the material constant. Controlling these background variables locks in the reliability of your data, proving to the examiner that your test was 100% fair. But here is where the pressure test really ramps up. Knowing your variables just isn't enough if you end up collecting the wrong type of data. Like, do you actually know right now if your data is continuous or discrete? Well, in a moment, I'll show you the exact examiner clue that completely changes your answer strategy. But first, you need the framework that makes that clue obvious. If you bounce from this explainer now, you're going to miss the exact data type clues the examiner looks for, and your graph plotting will totally fall apart. So stick with me. To design top-tier tables and graphs, you must master the 3 core types of data: categorical, continuous, and discrete. Your measurement techniques and even how you categorize information depend entirely on understanding which of these 3 you're dealing with. Let's break down how this translates into actual, practical exam knowledge. Spotting the precise difference here is absolutely crucial. Categorical data is sorted into groups that can't be neatly ordered by numbers, like the names of different materials. Wood, glass, plastic. You get the idea. Continuous data, on the other hand, can take any numerical value within a range. Take the temperature of an object. It could be 20 degrees, 20.5, or even 20.55 degrees. It slides on a continuous scale. But discrete data, that can only take certain specific, separate values. Like the number of protons in an atom. They have to be whole numbers. You can't exactly have half a proton. Knowing these exact differences dictates exactly how you record your results and plot your axes. Okay, let's escalate the stakes a bit and apply this entire framework to a real Cambridge-style worked example. Consider a classic physics 0625 scenario: light emerging into the air from semicircular blocks made of different materials. The goal of the experiment is to find the critical angle for these different blocks. This setup specifically tests whether you can extract a flawless experimental design from just a simple text description and a basic diagram.
I want you to actively engage with this for a second. Just pause and predict. For these semicircular blocks, what is the independent variable and what is the dependent variable? Take a mental snapshot and lock in your answer right now before I reveal the examiner-style correction. Remember the definitions we literally just covered. What are you actively choosing to change, and what are you measuring as a reaction?
Okay, let's expose that classic spot the error moment. A flawed answer here usually involves really vague descriptions of the blocks, or students confusing the light ray itself with the variable. The perfect top-band answer is incredibly precise. The independent variable is the material of the block. And notice that is categorical data. The dependent variable, the one you're finding the value of every time you swap the block, is the size of the critical angle. And this brilliantly highlights our ultimate top-band answer framework. When you structure your exam answers, you need to flow from the core concept to the evidence or data, apply your scientific reasoning, and cap it off with precise examiner wording. By clearly identifying the block material as the independent, categorical data, and the critical angle as the dependent data, you're perfectly structuring your scientific reasoning. You've proven to the examiner that you don't just know what a critical angle is, you know exactly how to measure it in a highly valid, scientific way. So, you've mastered identifying your variables, and you now know exactly how to classify your data types. That's huge. But how do you integrate this strategy when the exam is literally just days away? Knowing your variables is a great step one, but if you don't know how to allocate those highly crucial final revision hours, your overall score is still going to suffer. We have a new, very urgent problem to solve. To solve that exact problem, you must watch our next explainer. We're going to take the exact framework you just learned and plug it directly into an ultimate last 7 days revision map. It's the mandatory next step to make sure you aren't wasting hours on the wrong topics. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Go click that next explainer right now to rebuild your revision strategy stronger. Because hey, if you can't control your own study variables, how can you expect to control your final grade? I'll see you over there.